Okay, so the requirements section is a very short one because most of the requirements would have been done through the feature section. So you've already said what features are going to be in your system. What you really can do in this section is just kind of like flesh out a few details on the hardware and software requirements. So now, normally we split this into two parts. The first section is optional, in all honesty. It's more useful for you in terms of planning out your prototypes and how you are going to, decide on the order of it, what you're going to be doing. And the second one is mandatory. You have to do the second one. So user stories, I mean, again, this is optional. If you don't want to do it, that's absolutely fine. It's not a long section. It's a 10-minute job, in all honesty. And all you do is you make a list of all of the features. So we call these user stories. Okay, so it's kind of a throw into Agile. And what you do is you decide how important each story is. So for each feature that you're going to be implementing, you decide, well, is it high priority, as in it must be there, without it you can't really do much else? Or is it low priority, one of those kind of nice features to have, but it's not necessarily essential, it will still work without it? Then you give it a score, and this score is a number, and that number can range, I mean, in all honesty, can range from anything really, so from 0 to 100 or 0 to 10. It doesn't really matter, because what this number is representing is, well, how long do you think it would take you to develop it? Okay, this is not like in days or weeks or months, anything like that. It's just a number, a relative score to all the other features. So if you've got a feature you think, oh, this one's going to take me ages, you might not know exactly what ages means. You might not know if it's like 10 weeks, 10 months, or whatever. It shouldn't be 10 months, but you get my point. But you might have another feature you think, oh yeah, I can knock it out in a weekend, easy peasy. Well, you've got a relative scale then, don't you? So you've got ages and easy peasy. So you can give that ages one maybe a score of 9 out of 10, for example, or maybe 90 out of 100. And then the one that's easier, the one that you think you do really quickly, maybe give it a score of maybe 2. So this story score becomes like your best guess of how long roughly you think it's going to take as a relative score to all the other features. Now, the reason why we do this is because the high priority user stories or features are ones you must do. Okay, so they have to be there. They're very likely going to be the core focus of maybe prototype 1 and 2. But you might decide, actually, well, I've got this really high priority feature, in this case, selecting flashcards adaptively. Okay, and then I've also got another high priority one. Well, can I do both? Do I have time to do both of them in my first prototype? Or it might be that you have a high priority one that you're going to do prototype 1, and then you maybe do 1 or 2 low priority ones, or 1 or 2 medium priorities, which don't take very long to do. So you can balance your time and decide how you're going to kind of arrange your prototypes and have a mixture of maybe these high and low priority kind of user stories based on how much time you think you have. That way you kind of spread out the features over 3 prototypes, and you're not just doing them in kind of like a very simple order, you're doing them in an order that makes sense. As I said, the last section is optional. You don't have to do it, it's just useful. And this one you must do. Now, hardware and software requirements are one of those kind of weird sections. That it's not a very long section. Again, it's probably half a page at most. And it's very dependent on the coursework and the project you are doing. So, it's really focusing in on what additional hardware do you need other than a computer. Now, for some of you, the computer in inverted commas might be a mobile phone, because this is a mobile app that you are creating. Maybe it's going to be based on the tablet or whatever it happens to be. So your hardware requirements of that device is very much going to be based on that thing. So if it's a mobile phone, maybe you choose an average mobile phone. If it's a tablet, average tablet. If it's a computer, again, you got to decide, well, is this going to work on a Raspberry Pi, for example? If it does, I'll use Raspberry Pi as my example of what CPU it needs, what RAM it needs. For those of you who are into PC gaming, you're probably quite used to system requirements where you have to, where it will say, you have to have this amount of RAM and this processor and then this amount of this graphics card in order to run the game. It's kind of along those lines. What is the kind of requirements to run your piece of software? Now, for the most part, you won't have a clue, in all honesty. So I would suggest kind of the specs of a Raspberry Pi is probably a good one to go for, unless you've got a specifically complicated algorithm behind the scenes. So something that is going to take a lot of processing. In that case, you consider time complexity of your algorithms and then up and increase the requirements as a result of that. If you have a project which requires more hardware, then obviously you've got something very clear to talk about. So if this is, I don't know, going to be robotics space, you can talk about Arduinos and all that kind of stuff. So you must quantify everything as much as you can do. You then must justify everything. Now, the justifications for a standard PC are literally just that. My program will run on a standard PC, and that's pretty much it. You don't need anything more than that. If, however, you need something more than a standard PC, that's when the justifications matter a bit more. Okay, so just to kind of summarize on that one, if in doubt, use the specs of a Raspberry Pi, and your justification simply becomes my app will run on a Raspberry Pi, therefore this is specs I'm going to go for. If, on the other hand, you have anything specific in there that is going to require a more meaty processor or graphics card or whatever happens to be, then you can give a justification to why, and you would have a reason why, wouldn't you? Software requirements, you may well write a lot more here. For the most part, this is going to be what libraries you're using. Now, remember, your coursework can't just be using libraries. It has to have that algorithm behind the scenes, that complex part to it. And your complexity can't just be, I'm using an API. But you can use APIs, okay? It's absolutely fine for using APIs to help you with your project. What you need to do in the software requirements is basically tell me what APIs you're using and why. Okay, and that's it. So what libraries you're going to be using, and why is it required in your program, and why have you used that one maybe over another one. You may require some additional software. So if this was going to be server based, you need server software. Okay, so what software would be running behind the scenes? If this was I know a database one and you had to run a database like MySQL, and then you'd include that as well. 90% of the time, there is no additional software other than the libraries you can be using. So to summarize, this is a really short section. You can have that optional user stories part where you list out those features and say their priority and how long you think they're going to take you relative to each other. And the hardware and software requirements are essential. You must put them in there, but the hardware requirements might be quite straightforward. I'm going to use Raspberry Pi, put the specs of Raspberry Pi in there, and then that becomes your justification. Or if you need something more, you can say what is extra that you need, and you can justify it. Software, you need to say what libraries you're going to be using and also the justification there one. So really, I think most of you can be spending most of your time writing about the software rather than the hardware.